Okay, data center design on cooling system. So what are the challenges in designing a cooling system in hot and humid tropical countries? So answer is hot and humid, where actually we cannot enjoy the free cooling and even need to spend more energy to treat the humidity. So actually for the design of the equipment, we need to meet the extreme outdoor the extreme weather throughout for the 20 years, or even some client request for 50 years. So what are the challenges, the next challenges that we might face? So it can be a global warming, and also if a tech park is full of data center, there will be a local heat island effects. So all these are the challenges in designing a data center for future. So why we need to cool the data center? Because the server need cooling. Because nowadays, you don't keep your money in your wallet, but you keep the money in the servers. And you don't keep your sweet memories in your album, but you keep them in the in the servers. So actually, the servers we need to take good care of the servers, so that, if let's say a failure happened to the servers, actually all your money gone. So instead of design a room to suit the servers, actually the other way is we can design the servers to suit our ambient temperature. That can really bring down our energy consumption. So what types of cooling system are based on the current market? So the first one is the conventional chill water system. Chill water system using chill water to cool the room air. So it's just like this hall. So they're using a chill water to cool the room air inside the room. So the second is a direct or indirect evaporative cooling, where you don't use chiller, you use the condenser water to cool the room air. But of course, in Malaysia or in tropical countries, the room temperature will be higher. So for these two cooling methods, the servers are air-cooled, meaning that actually you can hear the fan noise from the server, the fan noise from the server. So the third cooling method is direct liquid cooling, DLC or direct to chip, D2C. For this one, actually you delivers the coolant direct onto the chip, and then you remove the heat. So this one, but the other component of the servers are still air-cooled. So this system is partially air-cooled and partially water-cooled. But of course, you hear less fan noise. So from here, actually, you consume less energy. And the fourth one is immersion cooling, where actually you put the whole server rack into a tank with coolant. Then this server rack is liquid cooled. So you didn't hear the fan noise. So actually, it's more efficient for this immersion cooling. So just now we mentioned about the air-cooled server system. So what are the types of air-cooled server system? So the first one is the room-based, where this is quite common, where you always hear about the precision cooling, things of that. So actually you place the cooling unit at the perimeter of the data hall, then you cool the whole room, cool down the whole room. So you're using the crown or crack or fan wall unit to cool the room air. The second type is row-based. What is row-based is you actually sandwich the cooling unit in the same row of the server racks. So actually the hot air from the whole aisle pass through the cooling coil and then supply to the cold aisle. So the air actually travels in a shorter distance. So actually it's more efficient. And then the third type of air-cooled server system is a rack-based, where actually you put the cooling unit attached into the server racks. So actually the air is inside the server rack is keep on cooling within the rack. So this one is even better. Okay, then we go to the direct liquid cooling DLC. So DLC, just as I mentioned, actually is you attach the cooling unit direct to the chip, then the coolant actually remove the heat direct from the chip. So by doing this, you don't need the fan. You don't need to put the fan on top of the chip. So actually this system is more efficient. And then the PUE is about 1.2 to 1.3. So what is PUE? Is a power usage effectiveness. The lower the value, the system is more efficient. Okay, the last cooling system is immersion cooling. So actually you put the whole server rack, you submerge the whole server rack into a tank with coolant. And then there are two types of coolant. One is single phase, the other one is two-phase. For single-phase, actually, the hot coolant, when the coolant absorbs the heat from the servers, actually it will rise and then displaced by the coolant from the bottom. So this is using a buoyancy, so it's a single-phase. Whereas for the two-phase coolant, actually, when the coolant absorbs the heat from the server racks, it vaporizes to the gas phase. So when when we cool the gas coolant, then it will condense into liquid, then drip back into the tank. So these are the two differences on the immersion cooling. Okay. Then this is my last slide. I try to do it as soon as possible. So it's an innovative cooling system. What are the innovative cooling system? So actually, instead of using the clean water, we can use river water, sea water, well water, or even lake water to cool the system. So just like AI, they say that drinks a lot of water. But actually, we can feed the AI with a gray water. So then we can reserve the clean water for humans. So this is one way. And the other one is a free cooling from the regasification cooling. So actually, now we talk about the green energy. We're using a liquid natural gas or liquid hydrogen gas. So from the liquid hydrogen gas, when it degasify or vaporize into gas phase, actually it absorbs heat from the surrounding. So this, we can actually take advantage of this free cooling to cool our data center or our rooms. So from the gas, after the gasification, the gas actually can generate power using a fuel cell or a gas turbine, generate electricity. Then the electricity can supply to the data center or to other buildings or to the grid. So this is some innovative cooling system. So I think this ends my presentation. Thank you. Thank you.